Hello my dear students, I hope all you are fine in your home. Our first chapter 1, rational numbers. We know some different numbers. Do you remember that in KG classes? We have studied some rhymes. 1, 2, 3, 4, 5. Once I caught a fish and like. Do you remember that? Yes. First we study 1, 2, 3, 4 like that. We call that numbers as counting numbers. But in later classes, we study that as natural numbers. We know natural numbers, whole numbers, integers like that. What is natural numbers? Our counting numbers, right? Natural numbers. We are representing that numbers as capital N. That is 1, 2, 3, etc. What is the next number? We add 0 to that number. That is whole number. We represent that whole number as W. That means integer plus 0. That is whole numbers. 0, 1, 2, 3, etc. Then what is the next number? That is integers. We add negative numbers, negative integers to this whole number. We got integers. We are representing that as Z. That means minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. This is integers. Some other numbers also there, right? Half, 1/3, 3/4, like that, some fraction numbers. What we call that numbers? We call that numbers as rational numbers. We are such type numbers to these numbers we call rational numbers. There is a definition for that. Rational numbers, we represent rational numbers using capital Q. A definition: any number is of the form P by Q. P by Q. Some specialty is there, P and Q, where P and Q are integers. P and Q are integers. One more specialty is there. Q is not equal to 0. If Q is 0, what happened there? Q is the denominator here. If Q is equal to 0, then this is not defined. So, we write this condition also. Any number is of the form P by Q, where P and Q are integers and Q not equal to 0. This is the form of a rational number. We call this type of numbers as rational numbers. Let me check some numbers. Check 1, 2, 3, etc. Is this any rational number? This is not in the form P by Q, right? But we can write this number as 1 by 1, 2 by 1, 3 by 1, etc. Right? This is P by Q form, right? P and Q are integers and also Q not equal to 0. Therefore, these numbers are actually our natural numbers, counting numbers. This is also a rational number. Then what about 0? 0. Is it a rational number? Yes, 0 by 1. That's also equal to 0. This is P, this is Q, this is P by Q form. Q not equal to 0. P is 0, no problem, but Q not equal to 0. That we need here, Q not equal to 0. Therefore, this is also a rational number. Then what about the negative numbers? Minus 1, minus 2, minus 3, etc. Is this any rational? Here also we write minus 1 by 1, minus 2 by 1, minus 3 by 1, etc. This is also P by Q form, Q not equal to 0. Therefore, this is also a rational number. Then what about proper fraction, improper fraction, mixed fraction like that numbers? 2 by 3, 5 by 2, 13 by 4, 1 by 100, like that some numbers. What about here? These all are integers, right? Also, this is P by Q form, also Q not equal to 0. Therefore, these all are rational numbers. Then what about the decimal numbers? 0.1, 7.3, 0.34, like that numbers. These are decimals. This is not P by Q form, right? But we can write these as 1 by 10, 0.1 as 1 by 10, then 7.3, that is 73 by 10, also 0.34, this is 34 by 100. We can write these numbers as in the form P by Q, right? Here, this is integers and Q not equal to 0. Therefore, these all are rational numbers. Actually, these numbers, that means natural numbers, whole numbers, integers, all these are rational numbers. Mainly, we draw a Venn diagram. First, natural numbers, including 1, 2, 3, 4, like that numbers. Including that to 0, we got one number W. Then, including that to -1, -2, -3, that negative numbers, we got integers. Then including that we are to 1 by 2, 1 by 7, some fractional numbers, we got the rational number Q. That means natural numbers includes whole number. Whole numbers include integers. Integers include rational numbers. That means natural numbers, whole numbers, and all integers includes the rational numbers. Next topic, properties of rational numbers. So the properties of numbers, we have studied closure property, commutativity, associativity, some properties for integers, natural numbers, like right? Same all properties are here. First property, closure property. Our second property, commutativity. Commutative property. Third property, associativity. Associative property. Then we study distributive property. Distributive law. Then two more cases here. Existence of identity and also existence of inverse. And our next topic, properties of rational numbers. Here we discuss the properties of closure property, commutativity, associativity, distributive law, also existence of identity and existence of inverse. First we take closure property. Our first property, closure property. Here first we take closure property in natural numbers. In the case of natural numbers, how can we take the closure property? How many basic operations we have? Addition, subtraction, multiplication and division. We check that 4 operations in this property. First, addition. Take any two numbers in natural numbers. From 1 to infinity, take any two numbers. Here I take 2 and 3. These two are two numbers in natural numbers, right? Just add these two. What is the result? That's equal to 5, right? 2 and 3 are natural numbers. The sum is also a natural number. Therefore, natural numbers are closed under natural numbers are closed under addition. These two numbers are natural numbers. Sum is also a natural number. So we call these natural numbers are closed under addition. Then what happened in the case of subtraction? Here also take any two numbers. I take here 5 and also 5. Same numbers. What about subtraction? 5 minus 5. This is 0. 0 is not a natural number. Then what happened here? This is not closed under subtraction. Natural numbers are not closed under subtraction. Then check the multiplication. Take any two numbers. Okay, take 4 and your choice. 6. What is the multiple of 4 and 6? This is 24. Is this a natural number? Yes, this is a natural number. So, multiplication is closed under, natural numbers are closed under multiplication. Natural numbers are closed under multiplication. Then our last basic operation, that is division. I have it here. Taking number 5 and 7. Take 5, 7. These two are two natural numbers. Then 5 divided by 7 is a fractional number. This is not a natural number. Then what happened here? Division is not closed. Therefore, natural numbers are not closed under division. Natural numbers are not closed under division. So, in the case of natural numbers closed under addition. Why? Sum is a natural number, but natural numbers are not closed under subtraction. Why? In the case of subtraction, we got a whole number here. In the case of multiplication, natural numbers are closed under multiplication, right? But what is the reason? Product is a natural number. So, this is closed. Here, in the case of division, natural numbers are not closed under division. Why? Our result is a fractional number. That is not a natural number. Okay, you saw whole numbers and integers which are closed or not. Basic operations are closed or not. You check that yourself. Next, we check rational numbers. In the case of rational numbers, first addition. Take any two rational numbers. Can I take 1 by 2? Yes, 1 by 3. What is the result? Here the denominators are different, so you take the LCM of these denominators and take, we got 3 plus 2 divided by 6, that is equal to 5 by 6. This is again a rational number. Therefore, rational numbers are closed under addition. Rational numbers are closed under addition. Then check in the case of subtraction. Take any number 3 by 4 1 by 4. Take the subtraction of these two. We got this is 2 by 4. Here the denominators are same. So we minus the numerators only. 3 minus 1 equals to 2 by 4. This is actually 1 by 2. This is a rational number. Therefore, rational numbers are crossed under subtraction. Rational numbers are crossed under subtraction. Then what about the multiplication? Take any two rational numbers. 1 by 7 into 3 by 4. How to multiply two rational numbers? You just multiply the numerators and multiply the denominators. Here the numerators are 1 and 3. So 1 into 3 is 3. The denominator is 7 and 4. We multiply that. 7 into 4 equal to 28. This is also a rational number. So we write rational numbers are crossed under multiplication. Rational numbers are crossed under multiplication. Then what about in the case of division? In the case of division, take any two rational numbers. Here I take 1 by 2 divided by 1 by 3. What is the result? 1 by 2 into reciprocal of 1 by 3. That is 3 by 1. Here this is division, here multiplication. How we write that? 1 by 3 as 3 by 1. So the result is 3 by 2. This is a rational number, right? Division of two rational numbers is a rational number in some cases. What about in the case of 0? If 1 divided by 0, 1 is a rational number, 0 is a rational number, what happened here? 1 and 0 both are rational numbers. What is the result? 1 divided by 0. Is it 0? No, this is not 0. What is the result of this? This is not defined. So this is a special case. In other cases, rational numbers are crossed under division. But in the case of 0, this is not closed under division. Therefore, in all, we say not crossed under division.